Welcome to our lecture series on advanced linear algebra. So far, we have discussed about the system of equations and their existential solution and how to find the solution, what is the criteria for that. Then we have also defined the vector space and details of it also. Now, let us conclude what we have learned by solving one problem. I will consider a matrix, and related to that matrix, how to compute different subspaces and answering different questions concerned to that matrix. So, let me take a 5 cross 5 matrix, capital A equal to like this. So, it is a 5 cross 5 matrix over the say field is my real number here. Then I have raised couple of questions here. The first question is, find an invertible matrix P such that P into A is a row reduced echelon matrix. Then it is also question whether that matrix P is unique or not. Second question, find an order basis B for the row space of A. Third, which vector say beta equal to B1, B2, B3, B4, B5 in the subspace W, and find the coordinate matrix of beta with respect to order basis B. Then 4 more questions, what is the general element of W, and what will be the structures of this solution capital X of the system Ax equal to 0, what will the basis for the solution space of the system Ax equal to 0, and for what set of 5 cross 1 column matrix the system Ax equal to y will have solution as capital X. Now, to answer these questions, I will consider in augmented systems and do the elementary row operations for the matrix A. So, let me write down. So, it is solutions. So, consider the corresponding augmented matrix, say A prime, which is equal to A and that say column, this ones. So, I can write down this A prime as 1 2 0 3 0. So, 1 2 0 3 0 and y1, 1 2 minus 1 0, 1 2 minus 1 0, y2, 0 0 1 4 0, 0 0 1 4 0, y3, 2 4 1 10 1, 2 4 1 10 1, y4, and the last one 0 0 0 0 1 and y5. So, this is the augmented matrix corresponding the system Ax equal to y. Since we have to find a matrix, an invertible matrix P such that P into A equal to a row reduced echelon matrix. So, I have to do the elementary row operations, so and get that matrix also. So, let me do it. So, if I do it, I will have this thing. The first row I will keep as it is 1, 2, 0, 3, 0, y1, because the first non-zero entry appear in first column, which is equal to 1, that is leading entry. So, it is fine. Now, to satisfy the second criteria for the row reduced echelon forms, all the entry of the first column must be, I mean apart from the first one, all has to be 0. So, that is why I am just writing that R2 goes to R2 minus R1 and R4 goes to R4 minus 2 times of R1. If I do it, what I am getting? I am getting here, so 0, 0, minus 1, minus 4, 0, y2 minus y1. Third row will remain 0, 0, 1, 4, 0, y3. Fourth one, it will be 0, 0, 1, 10 minus 6 will 4. Okay, so 1, 4, 1, y4 minus 2 times of y1, and this one will remain as 1 and y5. So, this is the updated one, but I see that this part inside the part is 5 cross 5 part, this is not a row reduced echelon matrix. So, we need a further elementary row operations we have to apply. So, if I do it, then I am getting 1, 2, 0, 3, 0, y1, this is as it is. So, I will do R2 divided by minus 1, so 0, 0, 1, 4, 0, we will have y1 minus y2, and R3 I will simply add with R2. So, I will have 0, 0, 0, 0, 0 and y2 minus y1 plus y3. Similarly, if I go for the R4, R4 replacing by R4 plus R2, then I am getting 0, 0, this will be 0, 0, 1, y4, okay, y4 plus y2 minus 3 y1, and the last row will remain as it is. So, this is y5. We see still it is not row reduced echelon matrix. So, what I will do? Again I have to do the next step. So, for that I am getting again 1, 2, 0, 3, 0, y1 and 0, 0, 1, 4, 0, y1 minus y2, okay, and I will replace fifth row by third row and third row by fifth row. So, if I do it, then I am getting 0, 0, 0 and 0, 1 and y5, and fourth row I am subtracting by fifth row. So, if I do it that one and keep it as it is 0, 0, 0, so I will have y4 plus y2 minus 3 y1 and minus y5, and last one, since I have shifted third row to the fifth row. So, this will be 0 0 0 y 2 minus y 1 plus y 3. So, I have got a new matrix like this thing. Now, you see that the first 5 columns, they satisfied the condition of the row reduced echelon form of the matrix, and it is also row reduced matrix. So, I can write this is equal to something like R and Z type. So, here R is equal to, I have got a sequence of finite sequence of elementary matrix has been multiplied from the left side to the matrix capital A, and if I denote that is equal to say P, then P into capital A, that is equal to R, and P into capital Y equal to Z please. So, this implies P matrix is basically coefficient matrix of the Z columns. So, this means that P will be here 1 0 0 0 0, second row will be 1 minus 1 because coefficient. So, coefficient of y 1, y 2, y 3, y 4, y 5, we have to check it. Coefficient of y 3 is 0, so it is 0, similarly like this, and then 0 0 0 0 1, and fourth row will be minus 3 1 0 1 and minus 1. Fifth one will be minus 1 plus 1 plus 1 0 0. So, this is the P matrix. See, I can write down fifth row as a fourth row or fourth row as fifth row. So, this means that I can have different P matrix. So, therefore, this P matrix what we have obtained here is not unique. So, P is not unique, but P it is clearly is an invertible matrix please. So, note that P is not unique. I hope this is clear why it is not unique please. So, this is the answer to the first questions what we raised in the very beginning, find an invertible matrix P such that P into A is a row reduced equivalent matrix R. So, let me rewrite this once. So, we have R is equal to 1 2 0 3 0, 1 2 0 3 0, and then 0 0 1 4, 0 0 1 4 0, 0 0 0 0 1 0 0. Okay. So, this is my R, but this R is unique. For a given matrix A, we will have only one row reduced equivalent matrix please. Now, my second question was find an order basis B for the row space of A. Already we have proved the row space of A, row space of A is basically row space of R. Now, in R there are 3 non-zero rows. We have already proved that all the non-zero rows of row reduced equivalent matrix will be linearly independent and span the row space of R. So, therefore, if I denote, let row 1 equal to 1 2 0 3 0 and row 2 equal to 0 0 1 4 0 and row 3 is equal to 0 0 0 0 1. Then B equal to row 1, row 2, row 3, is an order basis of row space of R or A. This is the answer to the second questions. Now, what is the third question? Say which vector beta which is equal to B1, B2, B3, B4, B5 is in W. Let W denote the row space of R. For any beta equal to B1, B2, B3, B4, B5 belongs to W implies that I will be able to express beta as LC of rho 1, rho 2, rho 3. I mean to say there are constant C1, C2, C3 over the field real number R such that your beta which is equal to B1, B2, B3, B4, B5, this will be equal to some constant C1 into rho 1 plus C2 rho 2 plus C3 rho 3. This is equal to C1 into 1, 2, 0, 3, 0 plus C2 into 0, 0, 1, 4, 0 plus C3 into 0, 0, 1. So, this is equal to the general element beta will be of the form of C1 comma 2 times of C1 comma and C2, then 3 times of C1, 3 C1 plus 4 C2 and then C3. Okay. So, general element is of this form. So, this implies that I can immediately compare in the coefficients from the both sides. So, this implies that B1 equal to C1, B3 equal to C2 and B5 equal to C3. Already we have proved in our last class for a general M cross N matrix what will be the relation between coefficient C1, C2, C3, C4 and the entry of the beta matrix space. So, generally this C1 is equal to Bk1, C2 is equal to Bk2 and C3 is equal to Bk3. That is also in that way also one can directly write down the solutions without comparing the coefficient also. But anyhow this is a very 5 cross 5 problem. So, it is not difficult for us to calculate the coefficient C1, C2, C3. So, immediately I see that C1 equal to B1, C2 is equal to B3 and C3 equal to B5 please. Here K1 equal to 1, K2 equal to 3 and K3 equal to 5. So, the column number in which leading entries appear in the row reduced echelon form please. Fine. So, this implies the coordinate matrix of beta with respect to order basis B which is equal to C1, C2, C3 transpose which is equal to I am getting as B1, B3 and B5 transpose please. So, this is the coordinate matrix of any element beta belongs to W please. And what will be the general element in W? Note that B4 equal to 3C1 4C2, 3C1 plus 4C2, this means 3 into C1 is equal to B1, B1 plus 4 into your C2 is equal to B3, so 4 B3. So, this is one, and another one is your B2 is equal to 2C1, B2 is equal to 2C1. This implies that what? Your B2 is equal to 2 times of B1. So, this implies beta equal to B1, B2, B3, B4, B5 will be in W provided B2 is equal to 2 B1 and B4 equal to 3 times B1 plus 4 B3. So, this is the condition for that is B1, B2, B3, B4, B5, so that beta will be in W. So, these are the two condition case 1 and 2, I can say like this. Or I can say that beta will be of the form of B1, 2 B1 and B3, then 3 B1 plus 4 B3 and B5 is the general structure of element of W, that is row space of your R. Interested to find all 5 cross 1 column capital X such that Ax equal to 0. I mean solution space of the system Ax equal to 0. Now, the solution space of the system Ax equal to 0 is equivalent to solution space of the system Rx equal to 0. Therefore, let us quickly see what is Rx equal to 0. So, Rx equal to 0 means we are having 1, 2, 0, 3, 0 and 0, 0, 1, 4, 0, 0, 0, 0, 0, 1. So, this is my R matrix. So, this means that I am getting the system 1 I mean x1 plus 2x2 plus 3x4 equal to 0 and x3 plus 4x4 equal to 0 and x5 equal to 0. So, I am getting 3 equations. Now, I can immediately solve it and I can tell the solution space of this system Rx equal to 0. Written x1 plus 2x2. Okay. So, I have this one. So, this implies that I can write down x1 as a explicitly function of x2 and x4, x3 as a function of x4 and x5 equal to 0. So, this means that I am getting x1 is equal to minus 2x2 minus 3x4 and x3 equal to minus 4x4 and x5 equal to 0. So, this implies the general solution capital X will be of the form of minus 2x1 minus 3x4 and then I can say x2 and x3 is equal to minus 4x4 and that is x4 0. So, this is the basically the general structure of the solution of the system Ax equal to 0. Now, to find the basis for the solution space, what I will do, since there are two variables which are x2 and x4 which are considered as a free variables. So, to find the basis of solution space V, we consider x1 is equal to 1 and x4 equal to 0. Yeah, x2 is equal to 1 and x4 equal to 0. So, this means that I am getting x1 will be minus 2, then x2 is equal to 1 I have considered, x3 is equal to minus x4, 4x4. So, x4 0 should be 0 and yeah, next is also 0 and 0, okay. This transpose. So, this is one solutions. So, this is, let me consider small v1 and now again putting x2 equal to 0 and x4 is equal to say 1. This will give me putting x2 equal to 0. So, minus 3, 0, minus 4, 1 and 0. So, this is, let me write down as V2. So, then B prime which is equal to consisting of V1 and V2 is the basis of solution space of Ax equal to 0. Since it has two free variables, so the dimension of the solution space will be 2. So, we need two linearly independent elements to which will span the solution space, that is V1 and V2 we have calculated. So, the next question was, for what 5 cross 1 column matrix Y the system Ax equal to Y has solutions. Now, we are interested to find set of 5 cross 1 column matrix Y such that the system Ax equal to Y will have solution, will have solution as capital X. Already we have seen the criteria for the existence of solution, that since in the row reduced echelon form of the given matrix A having 3 non-zero rows, so therefore, in the augmented systems that y4 plus y2 minus 3 y1 minus y5 has to be equal to 0. Similarly, in the fifth row y2 minus y1 plus y3 has to be 0. Equal to 0. Other one is y2 minus y1 plus y3 has to be equal to 0. So, these are the two conditions 3 and 4. So, all set of capital Y whose entries are y1, y2, y3, y4, y5 satisfies condition 3 and 4. For that set of capital Y, the system Ax equal to Y will have solution as capital X, provided the entry satisfied these two relation, please. So, this is all about the different question I raised related to the given matrix, please. I hope this will give a clear cut picture about what we have learned so far related to this course, please. Thank you.